team. So Scale FreeBack is an ERC Advanced Set Grant 2015 awarded to Carlos Canudas DeWitt, Director of Research at National Center for Scientific Research. So the aim of Scale Free is to develop control methods of complex network system and to set the foundation for a new control theory. So during 5 years we have to work on this problematic in order to try to find a solution. So now let me introduce my team. So I will introduce our first PhD student. He's a French. It's Stéphane Mollier, who is going to present his work.
So hello, I'm a second year PhD student and I'm working on traffic modeling, more specifically on an extension of some existing model of traffic in one dimension to describe traffic on a single road, to some two-dimensional traffic model that can be used to describe traffic over an entire network. And this kind of model are based on partial differential equation, can describe the evolution of density over time and space. There I have one example of my simulation. On the left you have my 2D model, and on the right you have some microscopic model that I use to compare.
So let me introduce you our new PhD student from Belarus. She's Lyudmila Tumaj and she's going to present her work.
Okay, so I'm new, so I didn't start yet, but the focus of my research will be to develop the control of large-scale urban networks. So this is a model which was presented by Stéphane very recently. So I will have to develop the methods of control applied to this 2D model, which models the traffic as a fluid on 2D space. And in particular, I will study the problems of controllability, observability, temporal dependence, and stability. Thank you.
So now let me introduce you Nicolas Martin, who is our French PhD student. So he's going to present his work.
Thank you. So this is the city of Grenoble, and when we deal with large human traffic network, we have to deal with large-scale network, and it is sometimes difficult to have some computation with a large dimensional model. So what we want to do is to find some partition of the network, so some zone, and by doing this we have a reduced network which is more easy to study. One particular structure of network is called scale-free network. This is network that we have a particularity. They have some big hubs which are nodes with a lot of connections. These networks are really interesting for us because without entering in details, they have some interesting properties for us. So what we want to do is to reduce an initial network into a scale-free network by preserving some properties.
I'm going to introduce Umar Niazi, our PhD student from Pakistani. He is going to present his work.
Okay. So what I'm doing is a like more theoretical work. It's based on large-scale network systems, and we need to estimate the state of the network system because the network system is evolving with time, and each state is doing some local computations, and yeah, this is the local computation at each node. So as the state of the node is changing, we need to estimate the state. But the problem is with large-scale networks is that you need to have a lot of sensors to be able to estimate. But what if we don't have a lot of sensors? Then what we do is we aggregate the nodes and try to find not the exact states, but the average state, or maybe some other aggregated quantity. And I'm developing these kind of estimators or observers to do that.
So now let me introduce you our new PhD student from Russia. is Denis Nikitin, and he's going to present his work.
So my work is devoted to control of aggregated quantities in large-scale networks. Idea is that it's really difficult to control the whole network, for example, traffic flow in big city on each intersection. So instead of control the whole network, we can just control some aggregated quantities like average value, deviation from it, and so on. So my work is just to design some control methods to check controllability, observability, and so on, not only controllability, for such network in sense of averaging.
Let me introduce Vadim Bertrand, who is the research engineer of the next team. So he's gonna explain his work.
Hey. Okay, so I'm gonna show you the two things, the GTL and the GTL-ville. So GTL stands for GrenoBle Traffic Lab. There are two web platforms where we show traffic conditions on the Grenoble area. So the GTL is there. It's dedicated to researcher mainly. So here you can see the current traffic condition on the south ring of Grenoble. So it's a road that is daily used for home to work traffic especially. And so with this platform, it is also possible to make some prediction of the travel time. So it allows us to know at which time it's best to leave if you want to use the south ring. And so lastly, I would like to say that all those data they are collected for all the road each 15 seconds, and they are available for researchers if they need it for their work. We have also been developing the GTL-ville platform, and here we would like to focus on the whole metropolitan area of Grenoble. So it will. Our goal is that it is more dedicated for general user, and so currently we only have the traffic condition. And so this view, you can have the traffic conditions per road. And we also want to try to display it as a zone traffic condition, so like this, by aggregated the roads by aggregating the roads. And in the future, because this is still under development, so in the future we want also to add pollution measurements and estimation, as well as travel time estimation, as we have done it with the GTL, and that's it. Thanks. Thank you.
And now, in order to conclude, I will present you Martin Rodriguez, a Colombian PhD student, who will present his work and conclude.
Well, hello. I'm going to talk to you a little bit about what I'm doing in my PhD studies. So our idea is to be able to reconstruct the state of a traffic network by taking information in a few places, so we can say how many cars are contained in all the streets in the city, for example, how fast are they moving, how many cars per hour are passing, and we can only do this with a few location sites. So for example, one of my first topics will be saying, okay, well, how many sensors we need to put and where to place them so we can actually do this. And then we take this information and do different type of processing. First, we base our studies using simulations such as this one, where we understand a little bit how is the movement in cars and their behavior in the city and in the network. And then, using some reconstruction methods, we're able to obtain this kind of results when we, in a dynamical way, we start reconstructing and estimating how many cars and how fast they are moving in the city. And in a future overview, the idea is to take this information to try to say how much fuel is wasted, how much contamination, pollution is being generated by these cars, and which is in direct relation to the air quality, for example, that our cities are living in the current world.